Periodic table gives us the atomic mass number, which is now effectively a useless unit, and we can shift into grams per mole. It's not completely useless. You do have to do conversions every so often with it, but it's not really all that useful anymore. So when you look at your mass on the periodic table now, what you should be seeing is the unit of grams per mole. That is known as your molar mass. Right? As an extra thing, you'll almost always see it gram/mole, and you should instantly do what to it? Do grams over mole, because that can help you go through with the dimensional analysis process that we've been working with. Right? To help kind of ease into dimensional analysis, again, what we're going to try and go through and do is do single step conversions as opposed to stringing it together, and see if we can get everybody onto the same page with that. Right? Because I think lots of people need that. Yes?
Okay, so just to make sure that I'm remembering correctly, so like 1 mole of lithium would be 6.9 for 1 over 1?
Okay, so let's draw a little periodic table here. We got lithium. We've got a 3, actually, because our periodic table has that differently, right? So 3, and we have 6.941. So what was the 3? Okay, that is the number of protons. I'll accept that, also known as the atomic number. Li would be the symbol for our lithium. And then our 6.941 is the, this is our atomic mass. If we look at it as units of AMUs, it is also our molar mass, which is not grams, grams per mole. Okay. Our AMU is also a fractional notation. Okay. It's just how AMU is represented, because again it's so rarely used, is it's your mass per atom. They just did some mumbo jumbo to shuffle that around to make it look neat, as opposed to mu over A, which just looks weird. Right? So we can pull that number off, and that is now our grams per mole of that type of element. Okay? So it is not the mass for that element, it is the mass per mole. We have to remember that complete unit system. Okay? Does that make sense? Okay? Questions on that?
When you're working with something with a very low AMU, and that's a low grams per mole, like
yes,
hydrogen.
Like hydrogen.
How do you work with 1 gram of hydrogen? What does that look like?
So I don't think I actually have a picture in these slides, because I put the picture of the different substances, a mole of a different substance, in the play posit video. Yeah, that's where it is. I'm positive it's not here because I just flipped through them. Right? So your textbook, if you go to chapter 8, does have a nice image that shows a mole of a variety of substances. Right? If you need help with that, I might be able to continue to lecture and flip at the same time. There it is. So a mole of substances will look like a variety of different things depending on the density of that substance. So you'll see varying amounts. And a gas of a substance, what is that going to look like? Well, it's a clear thing that we can't really feel. It's not. It's just going to be there. Yeah. So typically, if we're looking at our gases, we stash them into compressed or into cylinders, very high pressure, so they actually phase transition into liquids.
When you do moles, is it just in the natural state, or could you like have it in like a liquid state? So like a mole of sodium, could it also be liquid?
So a mole is just an amount of atoms.
So
It says nothing about the phase.
So liquid hydrogen.
So I can have a mole of liquid hydrogen. I can't have a mole of solid hydrogen because I can't get that cold. Okay? I can have a mole of gaseous hydrogen. Those are going to occupy different volumes because the different phases have different densities. Okay? But it's still going to be the same number of atoms. So, what can we do with the molar mass? Well, this is looking at ways to come up with different conversion factors. So, let's see if you can come up with the molar mass for copper 2 nitrite. Okay? I'm being kind of nice here because I gave you the formula. Okay? So, do the math, figure out the molar mass for copper 2 nitrite. If you got questions, raise your hand, I'll come to you. Okay, so where we will go ahead and start is looking at the mass for our copper, nitrogen, and oxygen from our copper nitrite. Sorry, copper 2 nitrite. Where do we find that mass information? The periodic table. So what am I looking at on the periodic table for copper?
It's
63.546.
63.546 what?
AMU.
Does everybody agree?
No.
No.
Molar mass.
Grams over mole.
The question is asking for the molar mass, which means we're looking for the mass, grams per mole, not AMU. AMU is the mass, an arbitrary mass unit
Atomic mass unit.
for an atom. Okay, so the AMU's isn't going to be, it's actually
Just like
funny.
an
Yeah.
arbitrary one.
Right. Needs to be grams per mole. If it was intentional, it was clever. As it was just funny. If you didn't catch it, don't worry about it. Nitrogen. What's the number for nitrogen?
4.006.
14.0067 grams per mole. Oxygen.
15.9994.
9994. So what do I do now?
Well, there's more nitrogen and oxygen.
Okay. So when we look at that formula to determine the molar mass, I need to know the mass of every single atom that went into it. Right? So all I've accounted for is one equivalent of each of those. If we look at our formula, though, there isn't just one oxygen for every nitrogen and every copper. There's 2 oxygens for every 1 nitrogen. Does that make sense?
Yeah.
Okay, so I would have to account for that. And I could go through and say times 2. Okay? But what else am I missing?
The fact that there's a 2 on the outside.
There's also a 2 on the outside that applies to the parentheses. So how many oxygens are in that formula?
4.
How many nitrogens?
2.
How many coppers?
1.
1. Okay? So now I could do all that math, add that up, and since a request was made to come up with totals, what do we have for a total?
155 and change, depending on which.
0.557.
0.557
It's 0 something. It
mole
stopped.
0. Okay. So a couple questions would come out of this. The first one, which came out of the back, what was your question?
Can you just make 14.0067 14?
I wrote 14.0067. Couldn't I have just written that 14? And then I'm hearing a similar idea for oxygen. Why not just write the oxygen as 16?
How many sig figs do you want?
There's the important question. How many sig figs do you want? Okay. That's what's going to dictate how many sig figs you should be copying off the periodic table. Okay. Remember, what we're building right here is a conversion factor that relates the mass to the moles for copper 2 nitrite. Okay. Because it is a conversion factor, I want to make sure that the conversion factor does not limit my answer. It is not my measurement. Which means for the conversion factor, I should string out as many sig figs as I possibly can, with some exception. How many sig figs do you want typically in your answers? 3. Okay, that's what our textbook told us to do, 3. Okay. There are plenty of cases where it's screwed up and it's saying different numbers, but 3 is what they're telling us to do. Okay, which means when I go through to add all of these things up, I want to make sure I have at least 3 sig figs. Okay? I would make the argument that I should have 4 to 5 sig figs. Okay? That way, my conversion factor doesn't limit my answer. Does that make sense? Is that a yes?
Makes sense.
Yes. Okay. So, back and to the back again. You asked, well, couldn't I have just written 14 and 16? Well, how much of a difference does that make in the end? It's going to be a really small difference. Okay? I, for one, know I suck at entering things into the calculator. Okay? So what I go through and do is I will approximate. 63.546, I'll probably write as 63.5 because I think I can hit those three buttons. Okay. 14.0067 is way too many buttons for me. I'll just write 14. 15.9994, I have a hard time even saying, much less writing. I'd probably drop to 16. Does that mean my conversion is going to affect my answer?
Not by much.
Not by much, but does it?
Yeah.
Yes.
Is
It's multiple choice. Do I care?
You should be.
Okay. So instructors, particularly instructors like me, will go through and put in wrong answers based off of a wrong calculation. Okay? The addition or rounding is not a wrong-headed mistake. That's a lazy mistake. That's going to put too many numbers in the same ballpark. Too many mistypes can make that happen. So I'm not putting those answers on the test. The answers I'll put on the test would be 63 plus 14 plus 16. Why would that go on the test?
Because you're just using the.
Because you're just using the symbols of the elements. You didn't factor in the amounts of each of the elements. Right? So what you're getting tested on are the larger conceptual things, not on your ability of the minutia of rounding and sig figs. So, on the one hand, be as accurate as you possibly can. On the other hand, know your instructor. Your instructor is lazy and won't go into the minutia for those multiple choice answers. Okay? Same thing on a show your work. What I'm concerned about are the larger grand scheme things, not your minuscule detail in dealing with rounding and sig figs. Okay? So could you get away with saying 14 and 16? Absolutely, because that's probably what I will do. Okay? When it comes to the test, I have to make it a very hard habit to take the periodic table that I print out with the exam and use the numbers on that and force myself to use those numbers whenever I run calculations. Okay? Because if I don't, that ends up putting in rounding errors that make everything a mess. Okay? So I will always use what's given to you on the periodic or on your exam. Okay? So, two answers. The official answer, carry everything. The unofficial answer, take advantage of your instructor's laziness. Make sense? Okay. Questions about that? Okay, so a question came up. Now that we've done all that work, I'm going to erase the work and just leave the number down there. They asked, well, when do I use Avogadro's number? Okay, well, let's come up with a circumstance for using Avogadro's number. One of the things that they asked was, well, what if I had 155.557, I'm sorry, 155.6 grams of our copper 2 nitrate. Nitrite. Okay. Would I use Avogadro's number now? Well, what does Avogadro's number convert? It's the conversion between atoms and moles. Well, I'm given a mass. Is mass atoms? Is mass moles?
Yes. No.
Mass is not a mole. Okay? Mole is a number of things. Mass is a measurement of said things. Okay? Those are two separate systems. So how could I come up with a way to determine or use Avogadro's number? Okay, well, let's say moles. Okay? Maybe I want to convert that gram into moles. So moles would go on top. What unit would show up on the bottom?
Grams.
Grams. Why grams?
'Cause that's what we
Grams
started
is
with.
on the top.
That cancels what I have in the numerator on the other part. You had that. Why are you upset?
Oh, because I was having a hard time with this, and I went and saw the math argument about it.
Yeah? And
They
it,
don't cancel. They create an equation that equals 1, so you're multiplying by 1. Nothing is canceling.
you're converting.
Right. And so
There's your-
every
okay.
time you say cancel, it goes away.
So the unit
That's where I wasn't getting it.
becomes converted.
Yes.
Okay? Let's switch up the English there. The unit is converted.
Yeah.
Okay? What we've generated here, which we've talked about on multiple occasions, is 1. Moles over grams is 1. Okay? That unit appears to disappear from our equation. Merely all that happened is we converted it into a new system. If that's all it is, that's awesome.
It's multiplying by 1, right. It was just the word cancel.
Okay, so I'll try my best to stop
So
using
you
it.
can use it now. That
Now
I
you
know
got it?
what you mean.
Okay. So we're now converting. Okay, which gets at the next step of this. We said I wanted to use Avogadro's number.
Right.
Is the relationship between grams and moles Avogadro's number?
No.
No. What is the relationship between grams and moles?
Atoms. Oh, wait. Grams of.
Grams per mole.
That was our molar mass. That was this number. Okay, so let's put that in because that is now the numerical relationship. 5, Gemini.
Carbon nitride.
For our copper nitride. And officially, we should be showing the copper 2 nitride, our substance, along with this. And we'd have 1 mole there. Right, but the whole point, I wanted to use Avogadro's number. Well, Avogadro's number relates moles and atoms. I had to convert the grams, because grams are not in Avogadro's number. Good?
Yeah.
Okay, so I'm now in moles. What did I want?
Grams of.
I wanted to use Avogadro's number, right? Avogadro's number uses the units of atoms and moles. What unit am I in?
Moles?
Moles. Can I now potentially use Avogadro's number?
Yes.
Yep. I can place moles on the bottom with the intent of converting that unit into something else. What is that something else I want to convert it into?
Avogadro's number.
Atoms. Okay? And this is one of the things that we, again, get lazy with on using moles. That is moles of what?
Copper 2 nitride.
Okay? Copper 2 nitride. Which then that means,
Atoms of copper.
that's close enough.
to
This,
nitrate.
what is the units for atoms?
AMU.
Copper 2 nitride. Can I have atoms of copper 2 nitride?
No.
Why not?
Atom's an element.
Atoms are single elements. Copper 2 nitride is not a single atom, it's,
You can have molecules.
I could have molecules. Does this change the identity of Avogadro's number?
No.
Okay, that's now MLCS. No, because Avogadro's number just says any unit,
It's a count.
a count, is a mole of that unit. Okay? It's not necessarily atoms is 1 mole. Why do we use it as atoms to mole? Because that was its origin, scaling the elements on the periodic table up to a measurable amount. That's why we came up with that number. But it can be for any unit, just like dozens. I can go into the store and buy a dozen eggs, and yet when I go to the baker and ask him for a dozen, he doesn't give me eggs. He gives me bread, bagels, donuts.
He'll also give you 13.
Okay? If I ask for a baker's dozen, I'll get a slightly different thing, because that's a slight variation off of that.
Then you get bread.
Okay? So, in our system here, what is the relationship between the molecules of copper 2 nitrite and moles of copper 2 nitrite?
It'd be 6.022 times 10 to the 23rd over 1.
6.022 times 10 to the 23rd molecules
Wouldn't that be on moles?
is 1 mole. Okay? When I convert dozens of eggs to eggs, is it 12 dozen eggs equals 1 egg?
No, it's 12 eggs.
12 eggs.
12 of the single item equals my larger item. Moles is my dozen. So the 6.022 has to go with our single item. Okay? Now I've used Avogadro's number, and I could go through and enter it into a calculator, and I have to clear up all that space. And we'd end up with an answer. Okay? Brady, does that work for using Avogadro's number? Yeah. So when I want to know the number of something present, then I can use Avogadro's number. That's the only time. Okay? If I want to know the mass, I'm not using Avogadro's number. I'm using the molar mass. Okay? Or some kind of calculation involving mass. Kind of makes sense? Yes? Okay? That looks like a lot of calculations, right? I'm not sure I could do that in my head. Let's see. Carry the 2, divide by 3. It's going to come out to be roughly 6.022 times 10 to the 23rd. Molecules of copper nitrite. How did I do that? 155.6 was the mass in 1 mole. Those units cancel. Those units convert, sorry. Okay. Which then leaves us with merely Avogadro's number.
So, in order to be credible, you have to show all that work and the end is just going to be Avogadro's.
Yeah.
Pretty much.
Yeah, that'd be kind of an irritating question, wouldn't it? You do all that work, be like, what the hell? Yeah.
Which means it's going to be all our show you know.
Okay. And in that kind of situation, if I wanted that work, that would be a show your work question, because in a multiple choice, it's just straight out of the gate, the answer. It should have been darn close to 6.022, because those numbers weren't perfect. I did 1 point, and I can't bring it back up. I did 155.6, I think, divided by 155.557. So they aren't a 1-for-1 match, but they're pretty darn close. So, new question. What is the mass in grams of 0.532 moles of copper 2 nitrate? What are we trying to solve for?
Grams.
Mass in grams?
Grams of water then, right?
Grams of copper nitrate.
Okay. The substance is important. It's not just the measurement, also include the substance. Okay. Ideally, you would go through and write out the chemical formula. How many of you still need to practice nomenclature? That's a lie. Everybody in this room needs to practice nomenclature. I saw your exam 2 scores. Okay. That's okay. I need to practice nomenclature. Okay. I suck at it too. Okay. If you don't want to write out the formula, write down something that makes sense to you. Like what?
Copper 2 nitrate.
Maybe C2N. Okay. I now have a notation that I know how to reference that I can deal with later on. What am I given?
45 moles.
So moles of my C2N, which was 0.532. Okay. I can't change the number, so we need to do some kind of conversion. We will be multiplying by 1, and that 1 has to come from a valid conversion factor. Ideally, what are we converting?
Grams to moles.
Moles of our copper 2 nitrite into grams of our copper 2 nitrite. Is the gram to mole relationship something that I am responsible for knowing as a student in this class? Two ways to answer that question. Okay. Both of them are yes. Yes, you're responsible for knowing it. How would you know it?
Reference the periodic table.
Go to the periodic table. Or rewind your brain or your notes like 5 seconds ago where we wrote down, apparently I was the only one that wrote it down way more times than I wanted to. Grams per mole of what?
Copper, nitrate.
Our copper 2 nitrite. What needs to go in there? Oh, exactly that. I now have my conversion factor established. My mole unit becomes converted into the grams of copper 2 nitrite. I now have my answer if I just enter that into the calculator. Hopefully what we're getting for an answer there, this one I would actually have to do ballpark 75. 82.75 ish. Okay, why ish?
Because I didn't, it goes out like 8 digits.
Okay, is this the correct answer?
Grams over, because we
You
wanted.
need to sort it in a bit better.
Yeah,
What's that?
sig figs, that's right.
Yeah, sig figs. That's what I was fishing for. Okay, officially that's wrong because that answer has 4 sig figs in it. How many sig figs am I allowed to carry through? 3 sig figs. So assuming your calculator did all give you 82.75, our answer becomes 82.8 grams of our copper 2 nitrite, and that's our answer. Make sense? Questions about that? Yes?
Why are we able to put C2N for copper 2 nitrate?
Why did we put C2N for copper 2 nitrite?
Because we hadn't memorized what copper nitrite really is.
We didn't know what the formula was because we weren't good at nomenclature, so we came up with a system that allows us to not write out copper 2 nitrite every single time. And since I don't know the shorthand for the formula, I'll just skip to some system that allows me to keep it there. It doesn't matter because as long as we track that unit, you're okay. And you know what it means. That's where putting it in at the top makes sense.
On the test with that food stuff.
Yeah, absolutely. Okay, particularly because it's specified. Okay, right up at the top there. Right where I have copper 2 nitrite, what did I do? I wrote C2N. Okay. Theoretically, your instructor who grades this would look at that and be like, you're horrible at nomenclature, but you're right. And give you full credit.
But wouldn't that throw off the grams? Because if you didn't know the formula, then you couldn't find the grams.
So there's an interesting point. Would you be able to get the 155.56 grams of copper 2 nitrite if you didn't know the formula? Ooh, nope. The only way we got that number was from the correct formula. If we don't know the formula, come up with something. Okay? Even if you wrote C2N, I at least have some context on where you're going from.
You can get copper and you can
You
get
still went down.
Okay? Hopefully you would get copper out of it. Hopefully you would realize you had nitrogen. The number that you came up with, if this was a show your work, would allow me to say you at least understand how to do the calculation, but you're so bad at nomenclature you can't answer the question that was originally asked for. Okay? You at least get some credit in a show your work. Even if you wrote C2N and did carbon and nitrogen, I at least have a context on where you're pulling your numbers from. Your numbers are wrong, but your conversion is correct. Okay? It's true. But again, a lot of this is about the process behind how you get the answer. In a show your work system, I don't care about the answer so much as I care about your process. Make sure your process is solid. Okay? If this is a multiple choice, you're kind of SOL. Okay? Make sense? Doesn't ease your fears much, but I would argue this question is not something I would put on an exam 3 because it requires that you know nomenclature to answer the calculation question. Right? On the final, it's absolutely fair game. Right? You can be expected for a single question to have to know multiple things to answer it and get it right. Okay? But on exam 3 or most of your exams, I try to keep those kind of questions limited to just 1 or 2 times. Make sense? I'm going to take that as a yes. So, atoms and mass. What is the mass in grams of 2.55 times 10 to the 23rd atoms of lead? Set up your work. Minimally, this needs to get written down, particularly for a show your work. Put it down. There it is. You've at least shown that you can interpret what the question is asking for. Okay? You've got some evidence. Now I can give you some credit. Okay? You give me nothing, I can't give you anything. Okay? So, first step.
Moles over atoms, because we want to get rid of that, get rid of the unit.
Okay? So, there's an argument that we should get rid of atoms of lead. Ideally, that would go to grams of lead. Is there a conversion factor that relates grams and atoms? No. What is the conversion factor that relates atoms? Fair enough.
So 1 mole to
Moles, or there's another one, the atomic mass. Most people tend to forget the atomic mass, but we could go through and solve this question using atomic mass. What is the conversion factor between the atoms of lead and the moles of lead?
1 over 207.2.
No.
1 over 2 times 10 to the 23rd.
All right, let's start with that one number. I'm going to say it's wrong.
Okay.
Why?
Because that's the grams.
The relationship to moles.
Thank you. 1 is meaningless. 1 mole now has value. I want the 1 in front of the moles. Don't tell me I want to do 1 over some number. Okay? If you don't know the unit system on where that number is matched, it's irrelevant. Okay? So it is 1 mole. And I know that's nitpicky and nasty, but do it. Okay? 6.022 times 10 to the 23rd atoms. Okay? This is a good case where we can go through and show this unit. Officially, this is moles of atoms of lead. Okay? No one wants to write that out, but that's what it means. Okay? A dozen eggs is 12 eggs. I'd have to include that statement all the way through. Okay? So the atoms of lead are now converted into the moles of lead. How do I convert the moles, or sorry, is the moles of lead my answer?
No.
No, so what has to happen?
Convert it again.
I have to have my moles of lead convert in such a situation where that unit, I have to say cancel. I have no other way to do that, so that it can cancel with our numerator.
Multiplies
Okay.
by 1.
We still got to reference the units apparently disappearing.
It does eliminate the unit. Yes.
Yeah, sort of. What unit do I want on top?
Grams.
No. Grams of lead. I know. Get the detail. Okay. Where do I find that conversion factor?
Table.
It's the periodic table.
207.2.
207.2 is wrong. 207.2 grams is better, but still wrong. 207.2 grams of lead is 1 mole of lead. Thank you. I can make the mistakes too.
Having already written it.
Yeah. All right. What unit would we be left with? Grams of lead. All right. So now it's a question of entering it into the calculator. Okay. And let's see if I can do this in such a way. Your calculator goes through and spits out
8.773.
8.7
738.
738 times 10 to the 46th.
Oh dear.
47.
47?
47.
Let's pick a number.
Did everybody get that number?
I never actually did math.
This would be a good point to be like, no, I didn't get that number. We just should discuss what happened there.
I didn't do the math out of it.
What did you get for that number?
I didn't get one.
You didn't get a number. Okay. What did you get for a
I
number?
got that number, but I didn't wrote it as, I wrote it as 8.7 grams of lead. But
So
I
you-
wrote it exactly like that.
You just got 8.7 grams of lead, not 8 times 10 to the 47.
I got it exactly like that in my calculator, but the way I wrote it was just that way. So I don't know.
Okay, your calculator told you times 10 to the 47? By you not writing it, you're saying, calculator, do all this work for me, and never mind, I don't want to listen to you. Your calculator tells you 10 to the 47, you better write 10 to the 47. Your calculator told you to do it. Okay, you cannot ignore that. Okay, there's a reason it's telling you. I think I saw Tyler first, but then we'll come back down.
I got 8.6.
8.6 times 10 to the 47 again? Okay, same mistake.
I didn't get an exponent at all. I just got 87.7382929.
That's what I got, yeah.
I can
Yeah.
explain.
Okay, so wait, well you got 87.73829.
73829.
Okay, I know, I see the hands. What's the difference?
I know it. There's the exponents on the
There's
top
an
and bottom.
exponent on the, what equation?
Something was calculated, probably didn't cancel out.
When you went through and did this calculation, you probably didn't include parentheses around those. Okay? Not if you got 10 to the 47.
It shouldn't be.
Okay. 10 to the 47
It should have canceled.
is wrong. 10 to the 23rd, numerator, denominator, what happens to your power of 10?
It gets canceled.
It cancels. We should not end up with a power of 10 that is that astronomically high. Okay? It's a calculator misentry. That number is invalid.
A lot of lead.
Yeah, that's a lot of lead.
Grams of lead just fills the hole.
Right?
That's pounds of lead.
It's significantly more than pounds of lead. Okay?
Could be a lot
Do we
of-
understand what happened with that mistake? I point out mistakes a lot, and I point them out so that you are aware of them and don't fall into that trap. Okay? Does everybody see this and understand what your answer was supposed to be? Should have been 87.73, which we'll address that number in a second, grams of lead. Okay? We good on that?
So
Take that as a
number's
yes.
gonna get me to the correct two answers on the multiple choice.
That number will probably get you right to the next one.
Really?
Yep, because there's too many calculations in there that involve conceptual leaps or conceptual thought process. I'm not going to ask a sig fig question because I'm now burning my answer choices. Okay? So more than likely you will see 5 answers, all of varying numbers. You'll probably see this 10 to the 47 show up in there. And you'll see multiple variations of those multiplications or divisions.
So I won't see 88.
Okay. You won't see 88 as a multiple choice answer. What you will see as a multiple choice answer will be
8.77
ah,
times 10 to the 47.
87.7 grams per lead. Grams of lead. Okay. You saw that number and started getting confused again. Okay. Make sense? Okay.
I'm thankful we're doing that.
Yay, another one. How many fluorine atoms are present in 2.25 grams of fluorine gas? Okay. Let's address some nomenclature stuff right out of the gate. What is the symbol for fluorine atoms? What is the symbol for fluorine atoms? F. Not F2, because F2 would then be 2 atoms, making it a molecule. It says fluorine atom,
So it's just an F
so it is just an F.
with the G.
What is fluorine gas?
F with the G.
That is now F2. Okay? Because fluorine is a diatomic molecule. we should always assume it is F2 unless it is explicitly stated atoms. That is an important distinction to make when we go through to solve this question. Have at it. This one, what are we trying to solve for?
Adam's F.
Atoms of F, what am I given?
Grams of F2.
Because I just found it to ask.
Grams of F2, what was it, 2.25.
Everything's right into that point.
Okay. So this is one where we have a variety of places that we can introduce a conversion factor. Okay? And depending on where you went with your unit system, you can do that conversion factoring at varying stages with slightly different units, but the meaning still holds the same. Okay? So let's go ahead and start. Grams of F2 and atoms of F. Is the measurement the same?
No.
No. Grams versus atoms, those are different measurements. Is the substance the same?
Yes. Well, no.
No.
No, it's F2 and F. So both the substance and the unit or the measurement have to change. The measurement we're used to seeing change. Right? To this point, there's only one way that we can convert the substance. How do we convert a substance?
Well, since the just a matter of F, just
In one water molecule, how many hydrogens do I have?
H2O. 2 H's.
Okay. In one molecule, we just said that, 1 mole of water, how many hydrogens do I have? 2 moles of hydrogen. Remember, mole is just a scalar factor. It's equivalent. Okay? So when we look at the black one that I wrote in here, really what I said but then didn't write was that in one molecule, it says molecule, of water was 2 atoms of hydrogen. What happened when I dropped down into here? 1 mole of molecules of water is 2 moles of atoms of hydrogen. Because the moles are equivalent on both sides of the equation, they could effectively cancel out. Those two relationships are identical. So depending on which one you have an easier time focusing on, you will use that conversion at a different stage in our formula or in our calculation. Okay? What do I mean by that? What is our conversion factor? We're trying to relate F to F2. What is that relationship? 1F2 is 2F. Where's the measurement? Atom of F is 1 mole of F. Sorry.
1 molecule.
1 molecule. That says molecule. Or 2 moles of F is 1 mole of F2. These are 2 different conversion factors that do mathematically the same thing. And depending on when I see that conversion factor show up, I may choose to use it then. Okay? If I don't see it, I can continue through the process and we'll end up using the other one at a later stage. Okay, so let's go ahead and start and see what happens. Is grams of F2 what I want for an answer?
yes. No.
No.
Atoms.
Atoms of fluorine.
Okay. So grams of F2 needs to get converted into something. What can I convert the grams of F2 into? Okay. Moles of F2. I swear I wrote a 2 there. Okay. Where do I find that conversion factor?
Oh, periodic table.
Periodic table. So I go up to the periodic table and I find out, because we're dealing with that notoriously lazy instructor, that fluorine, a single atom of fluorine weighs 19, right, or 18.9984 for those of us that aren't lazy. Right? So I could write 19 here and 1 there. No, why are you saying no?
There's 2 fluorine atoms.
There's 2 fluorine atoms. That's not 19, that needs to be 38. Okay. What unit would I be left with? Moles of F2. Right? And I would make the argument that we don't want to use the actual name fluorine gas, even though most chemists would freak out at that. The F2 highlights the fact that we have 2 fluorine atoms. If we just say fluorine gas, we could easily lose track of the number of atoms. Okay. Do I want moles of F2 as my answer?
No.
No, so I want to get rid of that. What can I convert the moles of F2 to? I could go into atoms of F2. Is atoms the proper word?
No.
That should better be written as molecules. Why molecules? Because there's 2 atoms in F2. It's better written as a molecule. So I could go through and put in my conversion factor, which is 6.022 times 10 to the 23rd
I love that number. Molecules.
molecules of F2.
I like this one.
Yeah, it just rolls right off the tongue, right? What's underneath? 1 mole of F2. What unit would we have? Actually, sorry, pause. Where do I find that?
Avogadro's.
That is Avogadro's number.
I don't know where I said it.
Let's just have fun with it.
Avocado?
Sure, why not? Right, everybody's going to say it that way anyway. Might as well just accept it. You're required to have that memorized. Right, so that has to come from your memory. What unit would we now have? Back to that question. We have what?
Molecules of F2.
What is our unit? Careful. Molecules of F2. Okay, not moles, molecules. Is molecules of F2 what we want for an answer?
No.
No, so what do we need to do?
Make it atoms.
Molecules of F2, and I want
Molecules of F.
So basically 2.
atoms of F. Did I have that conversion factor?
Yeah, 2 to 1.
Where did I get that from?
Right.
It's not a chemical equation yet. It's from the chemical formula. Okay? I said that conversion factor could come in 2 places. Where's the other place it could have come in?
Right at the beginning.
Not quite right at the beginning, because at the beginning I have grams of F2. My other conversion factor is moles of F and moles of F2, not grams.
So almost no.
This is our second step, right before we do the avocado number. Okay? Same conversion, we just end up alternating when we decide to do it. Okay? The unit has to change. Okay? And we have to do one or the other, not both. Okay? For the sake of calculators, oh, Jiminy Christmas. I heard 7 point what? 131. We need a times. Ooh, that actually stopped at 22. But let's write that a little bit nicer.
Oh.
Times 10 to the 22.
10 to the 22, yeah.
Where were we? Atoms of F. I heard at least 2 people confirm. Are we okay with that as an answer?
Sure.
Yes,
Yes.
enough. What's our enough? Sig figs. Okay, which again we've kind of addressed. You probably won't see explicitly on this test. How are we doing?
Yeah.
Good.
We only have 10 minutes left. Oh, gosh.
Really? Another one? Yes. What is the mass in grams of a single molecule of sulfur dioxide? The molar mass of sulfur dioxide. Look at that, I'm being nice. How am I being nice?
You gave us the formula.
I told you what the formula was, and
Then you told us how much.
I don't quite accept how much.
You gave us the 64.07 grams.
The 64.07 grams per mole of sulfur dioxide. I gave you the conversion factor between grams and moles. Admittedly, that wasn't a really nice gift because the periodic table also has that, but it you can now skip the addition. Make sense? Okay? Take a swing. Okay, I'm hearing grams over moles is given information. Yes, that's given. Is there anything else that's given? Yeah, the molar masses are 64.07, yeah, grams per mole.
So the question is the answer.
Nope, question is not the answer. What is the given information?
That we want,
Single molecule.
Say that again.
Single molecule, one molecule.
You are given one molecule of sulfur dioxide. Okay, that's your given information. Why is that tricky?
Because we already have.
What are you used to looking for to deciding your given information? A number. The number was actually written out. You're starting with one molecule of sulfur dioxide, and you're trying to convert that into, what are you doing? Grams of oh yeah,
Grams of a single
SO2. Sorry, I thought we were looking at just sulfur. I parsed it wrong in my head. So you have one molecule of SO2. You're trying to get grams of SO2. Right? You should now be able to work through this one a little bit better. Okay, it's tricky because that single was given information that was hidden in the text. Okay? One more thing before you rocket off to solve this one perfectly, because that's what you'll do. Okay? What should you expect for the number? Roar, roar, roar. Something really, really small. I remember the whole point of Avogadro's number was to scale things up so that we could actually measure them. If I'm looking at a single molecule, I'm looking at something insanely tiny. Right? It is so tiny that that mass should be insanely tiny, like on the order of 10 to the negative 23rd. Right? It's not going to be exactly that, but it's going to be close to that. With that information alone, I could probably whittle away some short or some multiple choice answers. Okay? So hopefully we're there. We had a conversion set up with molecules of SO2 converting into moles of SO2. What is that conversion factor?
1 mole of SO2 over 6.022 molecules of SO2.
Thank you for that hot fix on it. Okay, we now have moles of SO2. Is moles of SO2 what I want for an answer? No. What can I do? Convert again. Get rid of moles of SO2, or sorry, convert moles of SO2 to become grams of SO2. Where do I find that conversion factor? In the question or periodic table. So I can put 64.07 over 1. Can now enter it into the calculator, and I'd have my final answer. Who did it? 1.06 times 10 to the negative 22nd grams of SO2. Look at that. I said on the order of 10 to the negative 23rd. I'm pretty close. Only a power of 10 off. It's like scoring a 10 on the exam. That's passing, isn't it?
For sig figs, we need one more number, so it's 4 sig figs.
This is a bit of a weird one for sig figs because we're saying a single molecule. I am going to definitely say that let's look at another way to solve this. Yeah, don't stress on sig figs for this one. Is there another way to do this conversion? Yes, there always is.
Couldn't you use atomic mass?
I could use the atomic mass units, right, which is going to come out to be 64.07 AMUs is one molecule of SO2. How do I convert AMUs into grams? What? No one remembered that? Yeah, I don't blame you. 1.66 0.61 times 10 to the negative 24 grams is 1 AMU. Does the exact same thing. Okay? Except instead of having Avogadro's number on the bottom, we end up doing this mass conversion where it's in the numerator. We get the exact same answer. Questions? Okay. Before we take off, because what's going to happen is we're now going to move into chapter 9, which is our chemical equations. So all of the stuff we just did in chapter 8, we do again in chapter 9. Right? Chapter 9 just brings in the concept of chemical equations. So now I'm not looking at atoms within a formula. I'm looking at how one molecule can be converted into another molecule through a chemical equation. Okay? Very similar to how we might, say, build a bicycle, okay, or build a wheel. You will probably get sick and tired of that. Hopefully that means it sticks. All right? So where we will pick up on Wednesday is looking within chapter 9 and how we use chemical equations to do our conversions.